Hey, we're back with our final lesson from section 10.1, continuing forward. So in this part here, we're given a specific set of directions that, to simplify, and that assume that no radicands were formed by raising negative quantities to even powers. So if we're looking at a question like 69, where we have the square root of 16x squared, the 16x squared, the part under the radical, that's considered the radicand. And when they tell us that no radicals were formed by raising negative quantities to even powers, if we can assume that there were no negative quantities being raised by an even power, and basically that essentially allows us to not have to include the absolute value symbol around it anymore. So where I would normally write this as the absolute value of 4x, I can go ahead and write this now as 4x. No absolute value symbol. So know these directions well. Okay? So because we know that there's going to be no negative quantities being raised, then we don't have to worry about including an absolute symbol in our answer anymore. That removes it from the equation. Let's take a look now at 72. This would be negative the square root of 7c squared. Well, I'm going to go ahead and write the square root of 7c squared below. Put that in parentheses with the negative outside because I have the square root and the square undo each other. So that's going to be 7c. And then the negative comes along, and that's the best that I can do. You will notice here that compared to the work that we did in the beginning, we are still not representing this answer as 4x and negative 4x. We are not representing this answer as positive 7c and negative 7c. We're only generating one answer out of this still because we have the radical in use here. Okay? Just a few other problems to illustrate this example. Let's take a look at 73. We have the square root of the quantity of a plus 1 squared. And again, this is a square root, so the square and the square root undo each other. That's simply going to be a plus 1. You may leave the parentheses, you may not. That's your choice. Looking at question 75, this is going to be the square root of 9t squared minus 12t plus 4. Now, some of you may look at this, you may say, well, how do I figure out what this is going to be? You're in this section. Typically, the strategy is that these are going to be things that are going to be perfect squares. So if I'm trying to find what the factors are going to be, I know that 9t squared is going to be 3t times 3t. I know that positive 4 I can either get by plus 2 times plus 2 or minus 2 times minus 2. Because we have a negative 12t, it's probably going to be minus 2 and minus 2. If you check that, you should see, yes, that's going to give you a sum of negative 12t in the center. I'm going to go ahead and write this now as radical 3t minus 2, that quantity squared. Once the radical and the square undo each other, I'm going to have the value of 3t minus 2. Going to have with a few other questions here to trip you up. Question number 78. We're going to have negative the cube root of 64 y to the third. So in questions like this, when there are no negative values coming out, these answers aren't going to necessarily be impacted because the roots are not even. So we just proceed like we did with the other questions. We have the cube root of 64. Well, notice here, this y to the third is only on, this 3 is only on the y. We need the cube root of 64. So the cube root of 64, I can rewrite this as 4 to the third times y to the third. These will all undo each other, giving us just 4y. But I still have to bring the negative down, and negative 4y is going to be my final answer for that problem. Taking a look at one other problem here, let's say 82. A little bit of a tricky question. If I have 80, I'm going to have negative the seventh root of 1 minus x to the seventh. Well, most of you are probably guessing right now that the 7th root and the 7th exponent will undo each other, giving me the quantity simply of 1 minus x. If I have a negative on the outside, one way I could write it is like this. Another way, if we distribute the negative through, would be to write this as negative 1 plus x, or to just simply write it as x minus 1 by turning the x and the 1 around. So you may be asked to express it in this form. This form may be acceptable. This form may be fine too. It just depends on, what you may see on a test or what you may be asked to do. Okay, show you just one other question here, number 87. This is going to be the square root of x minus 2 to the 8th. So when you're looking at this here, if you have this square root here and you have this 8 here, the quick way to do this very simply is to simply take the exponent here divided by the root here. So you're going to have x minus 2 to the 8 over 2. And that's going to give you the quantity of x minus 2, and this has to remain in parentheses, raised to the 4th. No absolute value is necessary, but what it involves in this particular question, knowing this is a square root, I can put a 2 here. I have an 8th exponent, so I'm going to take the 8 for the exponent divided by 2 the root and get this outcome. This particular problem, or this particular property, will be explored in greater detail in future lessons, and I'll be glad to discuss it further in class. Thank you.